Pom 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 pom. La 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 la. Who's watching before the class really starts? I forget my own lines, and it's going to make things so weird. Aduh. For anybody who's seen that, kasihan delu. Oh, wait. Capacitance is. Coulombs per volt. Yejin, are you in?
Yes.
Does everybody know that there's a zoom on?
Yeah, I think so.
Okay. They're just taking their sweet time. All right. There's a lot of definitions for a farad. So I'm getting people asking me how to do the measurements and how do you measure in farads when the multimeters don't have farads. So
I don't even have a multimeter.
yeah, but multimeters are, if you're using them and you want to figure out what the capacitance is of your capacitor, it's measured in farads, but farads has like a million different, here, I'll show you what I mean, and I'll probably have to bring this up again later, but actually, can I do it this way? Can I center that? Can you see that in the top of the screen? Like, these are all definitions for a farad. It's coulombs over volts. I think it's area per second over volts, work per second over volts, joules over volts squared, Newton meter over volt squared, coulomb squared over joules, coulomb squared over Newton meter. It just, there's so many ways that you could potentially define this particular
I see.
define this particular quantity. So if you're having trouble measuring the farads, it's probably because it's such a derivative unit.
Not me, because I don't even have a multimeter, so I don't have a problem.
Okay. Knowing how many farads your capacitor is would help. Did you actually get it to work, Izzy?
This one? Yeah, it works.
Could you show me?
Yeah, I'll try. Wait, I'll try, but I don't know how this will work.
I'm so excited.
Can you see it? No.
I can see a battery.
Wait. Okay.
So you rolled it up, and you had one of the foil bits sticking out one end, one foil bit
Right.
sticking out the other.
Can you see it?
Yeah, I can kind of see it. Yeah.
Ah! Wait.
I'm so sorry, Jess.
What the heck happened? Wait. Okay. I'll try something. Wait. Ah. This is not visible, right?
I can.
Camera is pointing here. And the battery is okay. Okay. Wait a minute. Ah. Can you see the light?
Yes, I can see what you're doing.
Wait, no, this way. That's the light. This is the capacitor. This is the battery.
Yes.
Here is the switch. So I stick. Come on. Do you see the light?
Yes, I see the light. Very good.
Ah.
What happens when it goes up slowly? You can see that it doesn't just go ding, it slowly builds up in luminescence.
And then it goes down slowly also when I take it off. If I like let it go.
Yeah, it doesn't just go away. What is it different if you just touch it directly to if you short circuit it?
If I like remove this?
Yeah.
I don't know. The thing is, I taped it to the aluminum foil, and if I take the tape out, I think I'm gonna rip it.
Can you short circuit it is what I'm asking. Can you do a bridge between it? Like, can you touch the light switch directly to the end of the battery? I mean, the light directly to the battery, so it doesn't go through the capacitor at all.
Yeah, I can.
Can you do that? I want to see how fast it lights up and goes down.
Yeah, but the thing is, I have to take this thing off.
Okay, don't then. We'll see if what happens through someone else.
Try taking it out, but.
Oh, gently.
Oh.
I'll get to you in a second, Lydia.
No, get Lydia's first, because this is not.
It's okay. I'm asking Melody.
Okay. Okay.
How long do you want it to be?
If you're looking at measuring capacitance. Oh, wait. You have ohms there? So capacitance can be measured, farads can be measured as seconds per ohm.
Okay, then that means we need to make
You're muted, by the way.
Yeah, I didn't realize.
Yeah, but we can't make it.
It's all backwards, isn't it?
No, it's not. It's not.
Oh, it's not?
No, it's
For
not.
you, it's backwards. For us, it's not.
Longer than that track. Something longer than a track.
I am not sure.
Do you see that?
How about the track can be like this? Like,
Hold on. Because my micrometer is different.
Oh, yeah.
I mean micrometer, multimeter.
Okay, I'm just watching what you're doing, Yejin.
Ta-da. Oh, is that visible?
Yes.
Yeah.
Is it faster?
I'll put it to my hair because
Oh,
my
wow.
hair is black. So. And then it's faster.
Oh, it just goes tuk, and it just
that's so long.
Yeah.
What's the word? What's the actual correcting? It turns off quicker. Don't laugh at me,
Yeah.
Melody. I'm not using my Indonesian correctly.
Really
You can
Then-
see the difference. I would count that as proof that the capacitor works. I would count that as proof that your capacitor works, and you write it and just write it out. That that's so exciting.
I'm done with this project.
You've got
Is
that
that the only way
project.
we can prove that it works?
That's one way you can prove that it works. That the light doesn't just when the capacitor was there, the light dimmed slowly, and when the capacitor wasn't there, it just dropped. The luminescence.
Mr. Hindro,
What if we just use the multimeter to measure the capacitance? Can that also prove that it works?
Yes, you can. What you can do is you can use one of these definitions for capacitance.
whoa, okay.
So this is just from Wikipedia.
Mm-hmm.
But
Just confused. I haven't gotten a straight answer on what setting to use for my multimeter.
Right, so you will have to measure indirectly. Some multimeters will actually have farads on there. Otherwise, you can do it indirectly.
Which means, which one?
Measuring farads indirectly using a multimeter. Someone is going to have somewhere to do this. How to test capacitor with a multimeter in 5 ways. So somebody here must have something. Loading.
Can you see how weird mine looks? Wow.
You
Can
can.
you see yours? Whoa.
Let me just get back to that in a second. So they're showing.
Wow, that's fancy.
Testing.
This is how long. This is
Capacitor test.
how
Capacitor. Picofarads. Wow.
It's called a multi-tester. Is that something different?
Okay. Okay, so maybe what you want to be doing is checking your resistance. So they're suggesting here at about, I don't know what exactly the resistance you want to look at is.
2000, wait, was that 2000 or 200?
I had it on 200.
Okay.
This is so complicated. Isn't there just a simple thing, measure the resistance and then do something else?
Like when I do a battery, what number should come out?
If you just do the battery, it should have almost zero resistance. Your resistance should be nigh on nothing.
So we're gonna have to pull this in and go like that.
Like
Oh
what?
my goodness, this is complicated. So
Just
this
want to
one is,
know.
That.
I want to know too.
I know that.
Okay, so that'll tell you how to do it, but you're gonna have to do a lot of reading to figure it out. Inductance, capacitance.
Okay. Now we need it. Okay. Just first cut this part out, and you first cut that one when I go straight down. And I'll do this part.
테이프 없나?
Now we
Those
just
three.
여기 작은 테이프 없는 것 같은데. 아니 테이프 빵이라니. oops, sorry.
we have this.
Is there this symbol on your capacitor? I mean, on your multimeter?
Yeah, we have to cut down.
Hold on. What symbol?
It looks like a line and a sort of a curve connected together.
There's one that looks similar to it. This one.
Goes gonna go here, and the person's gonna.
That's it. That'll be it. That'll be it.
Stuck together. Well, if they're stuck together, then they're gonna.
So I change it to that one.
Same speed.
Yes, I think so.
They're not. Then you can go here, then here.
And that's to measure the capacitor.
Yeah, ensure power to the circuit is off.
So if I have like a little tiny capacitor that's like, what's it one? If I measure this, it should
Yes,
work.
it should work if you just touch the two ends.
Let's see. Moment of truth.
Is it already discharged?
Maybe.
Make sure it's been shorted first.
This would be good. Isn't Colin's job kind of like doing what they do?
Okay, now that I know the setting, I can work on it more. But
What reading came up?
nothing.
Nothing came up. Can you hold up the capacitor for a second and see if you can find the reading in farads? Oh, I can't quite see that. Just a second. In video, it's upside down.
Hold this.
Is it still upside down? Hold on. It says 10 volts.
Yeah, 10 volts is not what I'm looking for. It should be an F. There should be an F there.
Wait, which part is this one?
Oh goodness, I can't see that.
I can just read it to you.
Okay, just read it to me.
It says 47 UF.
It's not UF, that's micro. So
Yeah,
47,
whatever it looks like.
yeah, so it'd be 47. 47 or 37?
47.
47 microfarads. So if we have that in microfarads,
Yeah.
and you know the voltage of this. We know the voltage in a DC battery. Can we figure anything else out from the DC battery? We know the volts are 1.5. Actually, let's just see. Current per second DC battery 1.5 volts. So we can use a standard from we can use a standard for the current. So if you can figure out the current of a DC battery.
I put mine at the. Put it first, put it right like this. First on this. On the front part has to be facing this way.
Okay, that actually doesn't help you because you slow down the current flow with the. You will slow down the current flow using that. So you need to figure out. Measuring capacitance using resistance? Because you know the voltage difference across between the two plates will be exactly 1.5 volts.
I only need a board. We might need another thing like cardboard. $20. Okay.
Equivalent series resistant meters can conduct tests on capacitors while they are in a circuit, but do not measure capacitance directly. So that'd be what we're looking for. Okay, discharge the capacitor.
Can you move the due date for the test? It's too soon.
You don't have to take the test immediately. It's just there.
Yeah, it's due like next week Thursday or something, right?
I want to go.
Wait, are you serious?
Yeah.
Okay, should I push back that due date?
Yes.
Wait, how many homework questions did you assign us?
I assigned you 8, and we've gone through 4 in class. I intend to go through another 2 on Monday, and I want to go through the PowerPoint on Wednesday.
Can it be? Sorry. I was talking to.
If Justin needs to get changed, he needs to get changed.
What were we talking about? Oh, the test.
Yes.
Yes. Can it be at least like Friday or like the next week's Monday?
Yeah, sure. I can push that back to Friday, and we don't have a Zoom on Friday.
No. Next Monday.
Like Monday, like.
So what do we do?
So we have the weekend to take the test. Weekends are important.
Then we need to cut out.
You prefer to have the weekend for the test?
Let me enjoy freedom because I'm finishing my quarantine this weekend.
Goodness.
How many units are we doing until the end?
After we do this one, I want to do one more, but we may not get through it. We may only get through like two or three sections of it.
Okay.
And the last bit of the test, I'm asking you what you want to do for your final assessment, because I would prefer to get rid of. I'm going to just mute everyone just for a second. Manage participants. Mute all. So what I want to do is I want to get a final assessment of some sort. Now, it could be a short exam, like 10, 20 questions taken from the whole year or the whole semester. It could be 20 to 40 questions taken from the whole year, whole semester. That would be a more comprehensive one. We could do something that's more practical. Like you could pick videos. Each person does a video to showcase a particular physics concept for the next year. It could also be you guys design a circuit of some sort. One idea that was just rattling around in my head is you could make your own transistor radio if you can get the parts. I mean, I did it.
As a class?
No, it'll have to be individual. Now, transistor radios are not difficult to make. I can remember making one when I was 12. I can't hear you.
Are we talking final exam here?
Yeah, so basically it's can you pick up a radio signal?
Okay.
And the test would be is can you pick up a radio signal?
All right. So one more test for this section. One test for the next.
Next section, just finish with this chapter.
Wait, so two more tests plus a final.
I want this to be the last test of the year if you're not going to be doing the final. Okay?
What?
I mean,
Okay.
sorry, someone just walked past the window freaking out.
Okay, now I have.
What did you say, Lydia?
I would be quite happy for you guys to take this final test this weekend and then not have another test for physics. Because, I mean, you guys have basically been accepted into your colleges, correct?
Yeah.
So the grade is not something that's particularly important to your
My
mind.
grade matters because Mr. Hindra, I'm taking a gap year, so I need good grades for my senior year too.
All right. Okay, fine. Does that mean I have more leverage over you then?
No.
No. I do. I'm going to be so horrible when Becca gets to your age. She'll have to wrap around her little finger.
Wait, Mr. Hindra. So is this okay? I don't care. Wait, no, I do care, but like, so this chapter test, 17, the due date next Monday.
Opening up physics. Waiting. Classwork. Come on. Chapter 17, Giancoli. Edit. Due date, Thursday, April 30th. Better?
Bravo.
Yes.
Save.
Oh, amazing.
I hope this isn't too annoying for you.
What? How could it possibly be annoying for me?
Believe us, we'll get a good grade. I hope.
Monday, something of April. Monday, 4th of April.
Hey.
You can all thank Virgin.
Isn't it May or? Because April 4th has passed, hasn't it?
Oh, it's May the 4th. Star Wars Day. Handed in by Star Wars Day. I'll just put handed in by Star Wars Day. There you go.
Big picture. May the force be with you.
May the 4th. May the 4th. Okay.
Yeah.
Happy? Happy?
Yes.
Can I
My
see your
brother's birthday.
Can I see your capacitor melody? Did you make one?
Mine is a little assembler, and I'm not really sure how it works, but it works. And the multimeter was able to.
What do you mean you're not sure how it works?
No, because like I measured it using the multimeter, and it shows a capacitance, but I'm not really sure how. So I just used like a paper in between two tin foil.
Yeah.
And then I'm not really sure how it happened, but when I measured it with the multimeter, the capacitance measure went up to, hold on, let me see.
How many farads did you get there?
Whoa, wait, what am I doing? How do you
If I tilt the screen, it
read
doesn't
this?
actually let me see what you're doing.
Sorry. So basically it's just like that. I don't know how it works. And then you can see like the
It's not even connected to a circuit, is it?
Exactly, it's not.
Is that, are you touching the underside with the other?
Yeah.
Ah, okay, that makes sense. So you are making something that's like a circuit. Now that works.
So
That's how it should work. You're
that's how
building
it should work?
yes, you're
Why
building
does it work?
because you're building a static charge.
Oh. I'm not really comprehending that well.
Okay. So when you add charge to a capacitor, you're adding in static charge. You're literally getting a buildup of electrons on one side and a removal of electrons from the other. It's have you ever you know how we induced a charge in you can induce a charge by rubbing things together and your hair starts going out with that way. Well, that same sort of energy that causes your hair to go out on end in a field in that direction. If you can focus that field by the shapes between two parallel plates, the field is in one direction. So on one surface, you'll get a whole bunch of electrons, and on the other surface, you get none. And then when you turn the current off, yes, it's like creating a layer of electrons on one side and none on the other. So by applying that force into that field, you're moving all the electrons to the other end. And then when you turn it off, when you turn the power off, the electrons want to go back to equalize it again later. So it'll run the electrons back through the circuit, or keep running them through the circuit. That's why the light took longer to go dim for emitting. Okay, so you've made a capacitor.
So we can measure this without power.
You do measure capacitors without power because capacitance is also it's inverse per second your resistance, I think. Yes, it's the opposite of your inverse per second. Inverse resistance per second. Let me just share that again. The one that I think should be the one you're looking for is this one here. Draw, you silly machine. This one. Seconds per ohm.
Okay.
So if you don't have a unit that measures capacitance, you can do it as seconds per ohm. I don't know how you get the measurement of the seconds in there. Maybe you just see if it's stable.
This multimeter has microfarads.
Then that's fantastic.
Okay. And how do I use this to prove that it works, that there is a value for microfarads?
Yes, that proves that it works. But you wanna see if you can do it in a way that is in a circuit. Because by showing it via a multimeter, I mean technically you're proving that it works, and you can even do a measurement of how much it works. But if you can get it into a circuit and show that a motor starts and stops faster or slower, or a light lights up faster or slower, or a speaker, instead of it going, you know, sometimes when you turn a speaker off, it goes doo, and it turns off, and sometimes it goes doo. That zoom, that's the capacitor. When it goes doo, and it turns off quickly, that's without a capacitor, I think. Okay, so you want to be able to show that it works. At least that's for the expert level. If you just do it with a multimeter, I mean, it'll get you a passing grade.
Okay.
What the multimeter will help you do, if you wish to do it, is it'll help you make do a lot of formula work, because you can just plug in values to check how much capacitance this capacitor has. What was the capacitance of that aluminium plate that you made? Yeah, that thing. What was the capacitance of that?
Hold on. I don't know how to read this. Hold on.
What's it reading on terms of? I thought you had a capacitance setting.
Yeah, it's on the capacitance setting. It's I think it's measuring in microfarads, but I'm not really sure how to read it because the thing is not. It's like between 1 and 5.
What? 1 and 5 farads.
I'm not really sure how
Ooh.
this is reading. Hold on. No, not farads. Microfarads.
Oh, okay, that makes sense. That works.
Yeah, but I mean, why does it jump from 1 to 5 when before that it goes from
Is
0.2?
Are you absolutely sure that what's happening is these two plates are dead parallel and there's no like little bits in between them or some crinkles?
There are some crinkles. It's not.
That might have an effect. I'm not sure.
Okay. I can try it again with like another, like a more. So maybe if I make another one and then roll it, it would be more consistent.
I don't know.
Okay, I can try that.
This is one of the wonderful things about experimenting. I can leave this to you guys. I mean, you get to discover these things and truly comprehend it yourself. Kurang ajar Pak Hendro. Aduh.
Not too happy.
I'm seeing all of you guys getting some really good work done. What have you got, Weston?
Did you see the picture I sent on the group chat? So
Yes, I did. Why is it a 4? Why did you send me a 4 megabyte picture? Whoa, you've got the big 9-volt batteries there.
Yes,
How did that work?
it didn't.
It didn't. Why didn't it work?
I couldn't tell you.
Mr. Hendro,
How many connections do you have into it?
What do you mean?
Weston, I just want to show you something. You see that item there?
Yeah, that's the problem.
Yeah, that's a light globe that functions on a 220-volt AC circuit.
Yeah, I couldn't find it.
Yes, but what you have at the other end, are DC batteries. The light is incompatible with the power source.
I see.
You need to find some sort of you need to find some sort of DC application, whether that's a motor or a speaker or something that will be able to function on a DC circuit, because you have a DC power source and your light is an AC light. It needs to go with an alternating current. Whereas what you've given it is a direct power source where it just pushes the electrons through the system rather than has the voltage cycle.
But at the same time, I tried touching it with my finger and I couldn't feel anything.
Okay. So do you know the difference between a DC and an AC? DC and AC power?
I think so.
You think so? Okay. So tell me if I'm right then. The DC power source, when the power comes on and it runs through the cable, through the wire, it'll go in one direction. I'm going to turn that off because I can't hear myself think. When the power is going through, the electrons are moving through the system this way, in one direction. They go all the way back, and then they go all the way through again, and all the way back, and all the way through. And the battery normally that's supplying this power is pushing it in one direction. An AC power supply, this is my understanding, is that the electrons will move this way, and then they'll all move back, and then they'll move this way, and then they'll all move back, because the potential difference is cycling all the way up and all the way down and all the way up and all the way down. So it's cycling really, really fast. Like 50 times a second, you have the electrons go through the circuit. Now you design your equipment differently depending if it's AC or DC. That's why you need to have a DC application on a DC circuit and not a device that's AC. All right.
Okay.
Although I think that system will work though.
Okay.
It looks really good.
Where do I get an AC light bulb?
No. Don't. Doesn't have to be a light bulb. Do you have a Lego set
I
that
do.
has lights? That has lights?
No, not
No. What about a toy that would have lights that is battery operated?
Yeah,
The other thing you could do is you could get a flashlight.
I have a
And-
flashlight.
Open the top, pull out the thing that connects to the batteries. That can be a light that you can use.
I can give that a try, and I'll let you know how that goes.
Excellent. I'm excited that all of you have got one made. I'm very happy about that. Yes.
So I tried using this speaker that's to
Yep.
like a card that you open up.
Yep.
And the thing is though, like the sound it makes is like super scratchy.
Mm-hmm.
So then when I tried, like I also made this capacitor.
Mm.
And like, but it doesn't really work. So I'm wondering if it's like the speaker's problem or if it's like the capacitor's problem or what.
Or I could be very wrong, and speakers are a very bad example to use.
I think that's what I'm finding out.
But Mr. Hendro is wrong. That's a very.
Oh no, not that part, but just that the speakers
Oh,
are.
you already knew that, did you?
No, not. Trying to trap me with my own words. I'm finding that this particular speaker isn't working well with the setup. I don't know, because it's kind of like half broken, so it's not really helping.
Okay. All right. Well, I'm comfortable with what you guys have done. I'm very excited about this. This has worked better than I expected. I expected a lot more of this isn't working, but there's 2.5 successes here. No, I would say 2 successes and 2 half successes. So 3 successes. There we go. Yep, I'm very happy. No, you're not. Weston is a wonderful human being, valuable, and tries again. The important thing is to get up again when it doesn't work. This is a learning experience, Weston. It's not a failure. Okay? Okay. Ladies and gentlemen, singular gentleman. Thank you, ladies and gentlemen. Unless you have any other questions, I am quite satisfied with today's Zoom.
Thank you, and thank you for pushing the test. That means a lot to us.
Okay.
Thank you.
Bye-bye.
Thank you.
Thank you.